Sets. Sets are basically a collection of objects. So objects in the context of mathematics, we call it as, in the context of this chapter, we call it as elements. So what does elements mean? Elements can be words, numbers, symbols, and also alphabets. So for instance, let's say I'm having a Venn diagram here. So this is basically a Venn diagram. So Venn diagram is a diagram which holds a set. Okay. So let's say I'm drawing set A. I'm naming it set A and I'm writing inside numbers 1, 2, and 3. Okay. So let's say I'm choosing number 1. Let's say I'm just choosing number 1. So number 1 is immediately called as the element of set A. Okay, so number 1 is the element of set A. So how do we denote this? We denote this in this format. 1 is an element of set A. So you may wonder, what does this symbol mean? So this symbol actually means elements. And where does this come from? It just comes from this alphabet E from the word elements. Okay, so as you're aware now, you can see that inside set A there are more than one element, which means you can see number 1, 2, and 3. So all of these 3 are called as elements as well. So how do we denote this in one line, let's say? So we can denote it in 3 ways. So firstly, the way I prefer is you just write set A equals to, open up a cursive bracket, and just write whatever elements you find inside this set. Or in a more complex way, you can write it as x to the ratio of x equals to rows 1, 2, and 3. So which means x to the ratio of x equals to the number of the elements present in set A. Or in another way, you can also write it as, but this is much more complex, I think, x to the ratio of 1 is lesser than or equal to x, and 3 is greater than or equal to x, where x is elements of A. But somehow I prefer this method because it looks much more easier and much more clear for us to understand and to know what numbers or elements are present in a set. So next we are going to look at empty set. So empty set is just a total opposite of what the meaning of sets are. So sets, as we know the definition of sets, if you look at the beginning of the video, you would be aware that sets are a collection of objects, or we also call it as a collection of elements. But in the case of an empty set, which means there's no objects or also elements present inside a set. So for instance, let's say I'm drawing set B this time. So I'm drawing set B with no elements inside, so which means there's nothing inside. So set B is an empty. It's just same like a box which is empty, a jar which has no salt, and so on and so forth. You can just define it in your own ways. So which means that this set is empty. So how do we denote an empty set? Is we just write B and we just open and close a cursive bracket. Or in a much more easier way, you can just put a 0 and cross it. So I prefer this method because it's much more easier for me to remember 0 cross, which means a set and you just cross it out. So let's continue with subset. So subsets are basically sets which sub into another set, which means like you're having, for instance, let's take Asia. So Asia has Malaysia, Asia has India, Asia has China. So let's assume that Asia is a main set, and inside that set we can find countries like as mentioned before, and we can label them as subsets. So same goes to this part. So let's say I'm drawing set A now, and as you can see at the side there, set A has elements 1, 2, 3, 4, 5, and 6. And if you're aware, we have another set which comes inside this Venn diagram, which is called set B, which only consists of multiples of 3. And if you're aware, multiples of 3 are actually 3, 6, and so on and so forth. But for this case, since we only have 3 and 6 here, I'll just stop with 3 and 6. So if you're aware, B, elements in B, which are 3 and 6, are actually coming in A as well. So there's no point of drawing another separate set here, which is wrong. So what we can do is that we just draw set B inside of set A. So by drawing it inside of set A, we just label set B, which has elements 3 and 6. And in set A, we have elements 1, 2, 4, and 5. Okay, so which means that B is now a subset of A, which we can also denote it as B is a subset of A. So this symbol basically means, I'll just pull a line here, subset. Okay, I hope you are clear with this now. So now let's resume with equal sets. So equal sets are basically sets with same elements, which means, let's say if I have set C, all elements in set C are same as set D. For instance, let's say set C has numbers 4, 5, and 6. So set D would also have the same elements, which are 4, 5, and 6. So since the case is like this, we have no need to draw two separate sets like C and D like that. Rather, we can just draw everything into one set. So C, D, which has 4, 5, and 6, which means that set C and set D are actually the same set. So now let's move to literally the last part of this main chapter, which is union. So basically, when you see this word union, the most important thing which you have to remember is OR. So let's say I'm having I'll list down the elements of set A as 1, 2, and 3, and the elements of set B as 3, 4, and 5. So I'll also draw it down here. So set A and set B. So you may wonder, why is there a special meetup point over here? So the reason is because you can see that number 3 is actually repeating, so you just have to insert it there, and you no need to repeat writing number 3 in split sets, because it makes it look wrong in the context of sets. So 1, 2, 4, and 5. Okay, so now what the question is asking is, let's say the question is asking A union B. So this is the symbol for union, and I think it's very direct. The alphabet U, or the symbol U, comes from the word union. Okay, so A union B, or as I asked you to remember just now, it's elements in A or in B. So I repeat again, whenever you see the symbol union or you see the word union, remember the word OR, which means you have to choose elements in set A or in set B. So what are the elements in set A? 1, 2, and 3. Elements in set B, 3, 4, and 5. So you have to choose elements either in set A, so which means you have the possibility of choosing 1, 2, and 3, or you have to choose elements in set B, which means you have the possibility of choosing 3, 4, and 5 as well. So in this case, which elements denotes A union B? The answer is, it denotes all the elements present inside the set. Why all elements are included is because you have the possibility of choosing an element from A and also choosing an element from B are there, because the question is asking you for elements from A or from B. So which means either one, you can choose either one of them. So therefore A union B is 1, 2, 3, 4, and 5. So I hope you are clear with this. Okay, so now let's move to intersection. So as I said just now, union you have to use OR, but for intersection you have to remember the word AND. So what does the word AND mean is, you have to choose elements which are present both in A and also in B. So you have to see which elements are present in both A and B. Whereas for just now union, it's like you have to choose elements which are present in A or in B, which means you can choose everything. But this one, it's very clear. You have to choose elements only in A and in B, which means you have to see which elements are repeating in both sets. So if you see number 1, it's not coming in B. Number 2 as well, it's not coming in B. But number 3, only number 3, 4 and 5, it's not coming as well. So only number 3 is repeating in B. So what is the answer for A intersect B is automatically going to be just number 3. So we are just going to shade the intersecting part of this set. So I think you're getting it clear. Excuse me. I'm just choosing elements present in A and also in B, which is only number 3. And if you are aware, this is actually the symbol for intersection. And to remember the symbol of intersection, just I would usually choose this alphabet N, because N is written like that if it's a small letter. So I feel that they have derived this symbol of intersection from this alphabet. So that's all for this chapter. Thank you.